Brackets are an important part of mathematics, and this short video intends to summarise some of the key ideas involved in expanding brackets. Suppose you had the following question. This has got brackets in it. Now we can remove the brackets by expanding, and this involves multiplying. So we have a 4 times by an x, which gives us 4x, and a 4 times a 2, which gives us an 8. That bracket has therefore been expanded. Similarly, we might have 3 bracket 2x plus 5. We do 3 times 2x, which is 6x, and 3 times 5, 15. I now plan to go through a few more examples. This one looks a bit trickier, but it can be done in a similar way. We have a 2x times a 3x. Now 2 times 3 is 6, and x times x is x squared. So 2x times 3x is 6x squared. We now have a minus, and 2x times 5, which is 5 lots of 2x, is 10x, with the minus sign due to the subtraction within the bracket. Sometimes we get expressions which can have different parts to them. Now the general rule is try to sort out the bracket part first. So if we ignore the 5, we see how there is a 2 times x, which is 2x, a 2 times by a minus 3, which is a minus 6, and there's a 5 at the start, so we have a 5 and a minus 6, and a 2x. And the 2x part is by itself, so we have a 2x, but 5 take away 6 is minus 1. There are, of course, different types of brackets. There are also quadratic brackets. Now, for the sake of this, I just plan to show you a shortcut for working this out. We can draw the following structure, which tells us what to times together. Now, x times x is x squared. 2 times x is 2x. X times 3 is 3x. And 2 times 3 is 6. So we have an x squared, a 2x, a 3x, and a 6. We can write that down as x squared plus 5x plus 6. Now for these special types of brackets, observe how 2 plus 3 is 5 and 2 times 3 is 6. That gives us a shortcut for expanding brackets of this type. So for example, a shortcut. The x and the x gives an x squared when times together. We have a 10 and a 3, which gives us a 13x, and we have 10 times 3, which is 30. This this works when we have an x and an x here. The final one using the same logic. We have an x and an x times together, which is x squared. We have a 7, take away 3, 7 take 3 is 4, we have 4x. And finally, 7 times 3 is 21, there's a minus here, so that gives us a minus 21. So that is a short review on some types of brackets it is worth knowing for Module 3. This video looks at 3 routine algebraic calculations. Now when we're asked to expand, this means to times both terms in the bracket by the number outside. So 3 times 2y just equals 6y. Now 3 times 5 is 15, so 3 times minus 5 is minus 15. So this is the expansion of the given bracket. Now if we're asked to factorize, this means to go back into the bracket form. Now if we look at 8 and 4, we know that 4 is a factor of 4 and 8. I can also see an x in both parts of the question, so I can put 4x. Now to get an 8 requires a 2, but to get an x squared requires another x. 4 times 2 is 8, x times x is x squared. Now here is a 4xy, here's the 4x, so to get 4xy requires a y. So I have therefore expanded, so I have therefore factorized the given expression. Now in the third part, I want to rearrange this formula to get h equals. Now I've got t equals gh all over 10. So if I times by 10, I get 10t equals gh, which I can rewrite as gh equals 10t. So to get h equals, I'll have to divide by g. So h equals 10t all divided by g. I've therefore got h equals, so I've made h the subject of the formula. This question reviews the 3 main types of expansion. The first one is a simple linear bracket, and for this we times the things in the bracket by the 4 which is outside. So 4 times 3x is 12x, and 4 times 5 is just 20. So the answer is 12x plus 20, and that's the final answer. The second question, therefore, is just composed of 2 separate examples of the one above. So the first one becomes 2 times x is 2x, and 2 times minus 4 is minus 8. Then 3 times x is 3x, and 3 times 5 is 15. So I expanded that bracket and that bracket separately. And to finish off, we can simplify. 2x and a 3x goes to 5x. There's also a minus 8 and a plus 15. Well, plus 15 minus 8 is just 7. So the answer is 5x plus 7. The third one is then a pair of quadratic brackets, and for this we can use various methods. I tend to use what can be called the Smiley face method, which tells us what terms to times together. Well, x times x is x squared. 4 times x is 4x. X times 6 is 6x. And 4 times 6 is 24. I can then make my answer simpler by combining the 4x and the 6x. So the answer becomes x squared plus 10x plus 24. And that is my final answer. In this question we're asked to show an identity, which is that if we expand the left hand side, the answer will give us the thing on the right hand side. Now to expand this, we times the first bracket by x, so we get xy plus 6 times x, and I must take away an xy, but also take away a 4. Now xy, take away xy, cancel off, so I'm left with 6x take away 4. Now 6 and 4 have a common factor of 2, so I can factorise, and 2 lots of 3x is 6x, and 2 lots of 2 is 4. So when I expand and simplify, I get the answer as required. I've therefore shown the given identity. To expand a bracket, we times both things in the bracket by the number outside. So this just equals 3 times x, which is 3x, take away 3 times 6, which is 18. We have therefore expanded the bracket. Factorising is in reverse. The question is, what number goes into both 5 and 10? We're looking for the highest factor of 5 and 10. Well, 5 goes into 5 and 5 goes into 10, so we can put a 5 outside the bracket. Then 5 times what is 5y? Well, 5 times y. 5 times what is 10? Well, it's 5 times 2. Minus, so 5 bracket y take away 2. If you're asked to expand 2 sets of brackets and then simplify, the method is to expand both brackets separately. Now 3 times 4w is 12w, and 3 times 1 is 3. However, it's then minus 5 times by both these two terms. Minus 5 times 3w is minus 15w. But minus 5 times minus 2 is plus 10. Be very careful when there are two negatives. We then have to make the answer simpler. Well, 12w take away 15w is minus 3w. Then plus 3 plus 10 is 13. The answer is therefore minus 3w plus 13. With factorising, we have 3 terms here, and we're looking for 2 numbers which times to make the third number and may add to make the second number. And of course 4 times 2 is 8, and 4 plus 2 is 6. So, in the second example, 8 times 2 is 16, and 8 plus 2 is 10. Now, sometimes the signs can change. In the case where just the second sign has changed, the two numbers are timesing to make 16 and still making 10. So 8 and 2 are still the correct numbers, but to get a minus 10 we need a minus 8 and a minus 2. Now this still works because minus 8 times minus 2 is still plus 16. Because when you multiply, the two negatives cancel out and give you a plus 16. So the fourth example is similar. We're now looking for 2 numbers which times to make 6 and can somehow combine to make 5. Well, with practice and experience you'll find that 3 and 2, they times to make 6. However, if we have a minus 3 and a minus 2, then minus 3 times minus 2 is still plus 6, but minus 3 take away 2 is minus 5. So, we've looked at the examples where all the signs are positive, and then where the second sign is negative. The third case is where the third number is negative. So we have two numbers which times to make minus 10. To get a negative number, 1 must be plus and 1 must be negative. So two numbers times to make 10. But if I put a plus 5 and a minus 2 in, then plus 5 times minus 2 is indeed minus 10, but 5 take away 2 is 3. And in the final example of this type, we have a negative, so we need a plus and a minus. The numbers times to make 12. Well, 6 and 2 certainly work. If I put plus 6 and minus 2, that would make 4. I need a minus 4. So instead, I put plus 2 and minus 6, because 2 times minus 6 is minus 12, and 2 take away 6 is minus 4. The last example is called the difference of two squares. They are both square numbers. There are no x terms. This is a special case, and if I put plus 3 and minus 3 in, then x times x is x squared, 3 times minus 3 is minus 9, and the x terms, 3 take away 3, gives us no x's, they've cancelled out. And that again is called the difference of two squares. Now, one application of this is called algebraic fractions, where you try to factorize the things in the expression. So we have an 8 and a 6. We need to have two numbers which times to make 8 and add to make 6. Well, 4 and 2 times to make 8, and 4 plus 2 is 6. And then the things that are the same, top and bottom, cancel out, and we're left with 1 over x plus 4. The second one, we write at the top longhand, and then we recognise that as being the difference of two squares, which will be 4 x plus 3 and x minus 3. We look for what cancels, and we're left with 3 x add 3 x minus 3. And that is a simplified cancel down fraction. This video suggests a way to do the harder factorising, where the number before the x squared is not equal to 1. Now this method, you look at the number before the x squared and look for its factor pairs. The factor pair of 3 is 3 times 1. You then ignore, for the moment, the 7x and look for the factor pairs of 2, which is just 1 times 2. Now, to then factorise it, we use the following method. We put these two numbers here in a column, and then we put these two numbers next to it also in a column. And we try to pair the numbers off to make 7 in the following way. If I do 3 times 1 and 1 times 2, 3 plus 2 is 5, not 7. But if I do 3 times 2 and 1 times 1, 3 times 2 is 6, 1 times 1 is 1, and 6 plus 1 is 7. So this pairing off gives us a 7 as required. So to make the brackets, to actually factorise it, we put our two brackets down. Now, the first column tells us the x. So 3x for the first bracket and 1x for the second bracket. And this tells us that the 3 gets timesed by a 2. So the trick here is the 3x gets timesed by a 2. I must put the 2 in the other bracket. Because when you times brackets, you do 3x times by 2 like so. And the 1x gets timesed by a 1. So I must put the 1 also in the other bracket. So to show how this works, 3x times x is 3x squared. 1 times 2 is 2. 3x times 2 is 6x. 1 times x is x. 6x plus x is 7x. So we'll talk for this again for another example to show how it still works. So again, it's 3x squared. The only factor pairs are 3 and 1. But for the 6, it's either 1 times 6 or 2 times 3. So we have two options to consider, one of which will work. So I put the 3 and the 1 down a column. And I'll try and do the 1 and the 6 first. 1 and 6. Can I somehow make 11x? Well, 3 times 1 is 3, 1 times 6 is 6, 3 plus 6 is 9, not 11. 3 times 6 is 18, 1 times 1 is 1, 18 plus 1 is 19. So that doesn't work. So I can ignore that. But I can then try and do 2 and 3 instead. 3 times 2 is 6, 1 times 3 is 3, 6 plus 3 is 9, no. But 3 times 3 is 9, 1 times 2 is 2, 9 plus 2 is 11. So we've found again the correct configuration. So the trick here is to put it into brackets. So 3x and x, 3x and x. The 3x gets times by a 3, so I must put the 3 in the other bracket. The x gets times by 2, so I must put the 2 into the other bracket. And again, 3x squared, a 6, a 2x and a 9x gives the 11x. Now this method can be adapted to when the third term is negative, but we do the same technique with a subtle change at the end. So again, this one still is 3x squared, which is 3 times 1. Look at the 5, ignore the negative for the moment, that's 5 times 1. So 3 and 1, 5 and 1. And we'll somehow pair these off to make a 14, but one of them must be negative. Now watch this. If I do 3 times 5 and 1 times 1, I get a 15 and a 1, but 15 take away 1 is 14. So if I put a negative here, I get 15, take away 1 is 14, and 5 times negative 1 is negative 5. So, my brackets, 3x and x. The 3 gets times by a 5, so I put the 5 in the other bracket. But the x gets times by a negative 1, so I put the negative 1 in the other bracket. To show how this works, we get a 3x squared, a minus 5, a 15x and a minus x gives a 14x. So when it's a negative for the third term, one of those numbers must be negative. So for the fourth one, we've now got a 2 here rather than a 3. So that's 2 times 1. I've got a 3, which is 3 times 1. So I'll put the 2 and the 1 down here, and the 3 and the 1 down like so. And I must get a 5x, but a negative 5. Now watch this. If I look at this and do 2 times 3 is 6, and 1 times 1 is 1, 1 take away 6 is negative 5. So if I make that a negative, I get 1 take away 6 is negative 5, and 1 times minus 3 is also minus 3. So if I produce the two brackets, the factorising, 2x and x, the 2 goes with a negative 3, so the 2x goes with a negative 3, the x goes with a 1, the x goes with a 1, and again 2x squared, a minus 3, but a 1x, take away a 6x is a minus 5x. So that has now been factorised. I'll just finish by talking through one application of this. Suppose you were asked to solve 2x squared minus 5x take away 3 equals 0. Because we have factorised this into brackets, this is the same as 2x plus 1, x minus 3 equals 0. Now if two things times to make 0, these factors must be 0. So either 2x plus 1 equals 0. This tells us that if I take away 1 from both sides, 2x equals minus 1. So x equals minus 1 divided by 2. That's the first answer. The second one is where x minus 3 equals 0. If I add 3 to both sides, x will equal 3. And they are the two solutions to that quadratic equation. Now this method will work for some people, not for everyone. And another video I'll produce later on will show a longer way, but another way to factorise expressions like this one.